Welcome back, pilots. This is going to be an on-the-fly narration of a mid to long-range flight with my FT270. Stay tuned for after the flight footage. We're going to have a full breakdown of the build with components used and thoughts and opinions. This flight is using INAV 1.9, and the whole idea behind this build is to have a long-range 6-inch frame that has return-to-home capabilities. Crossfire is great, and I would actually love to use it in combination with the GPS. However, there are other things that can fail on a multi-rotor to prevent your drone from coming home. Most commonly would be video issues, so having a return to home feature to at least get the quad back to you safely if you have a component failure of that nature is a big relief and stress off your shoulders. Now, I always plan my long-range flights on Google Maps. I never fly in locations I'm simply not familiar with, and I always try and stay above some kind of landmark. Having the GPS coordinates is nice, it'll help get you close, but knowing where you last saw your quad is even nicer. And in this case, I'm going to be flying down an access road and then over some railroad tracks. But before I commit to flying over into this forest, I'm going to make sure that my GPS and compass is working properly. I put it in hold, do a couple banks and some yaw maneuvers just to make sure that the compass isn't freaking out and my home arrow is pointing towards me in the bottom left corner, which it is, so I'm confident, and here we go. I'm going to be making this entire trip on 25 milliwatts, and if you've seen any of my previous flights with this frame, you will notice right away as soon as we get further out that the video quality is fantastic, especially for 25 milliwatts. The reason behind this, which will be shown in the end of the video, is simply because of my FPV antenna placement. I finally figured out a way to mount the antenna in such a way that it doesn't look ugly, it keeps it solidly out of the props, and gives it fantastic reception. Also, knowing that you can go so far on 25 milliwatts with a clear picture is pretty darn good for confidence. I didn't intend to fly on 25 milliwatts, I meant to bump it up to about 200, which for me is always a sweet spot, but I forgot. The Mach 2 video transmitter that I'm using, unfortunately, every time you power cycle it, and it does this on Betaflight too, I don't know why, it defaults to 25 milliwatts, which is probably good for racers, but to be honest, in a long-range build, I would rather have it stay on the milliwatts that I put it so I don't have to switch it every time. So here we're going to join a little bit of beautiful smooth flight over these railroad tracks in the early morning with pretty much no wind. I think we might have an occasional 5-mile-an-hour gust, and you might see it in the video as a form of a jitter. But what I'm doing here is I'm actually flying faster than I normally would. This is above my cruising speed, and I know this doesn't look fast for any of you who are like racers or hardcore freestylists. Just simply for a cruising build, this is a little faster than I normally fly. When I fly at my average speed, I get about 8 solid minutes of flight time. Here I'm going to get about 7. So a minus a minute for a little bit of speed. But the reason I'm pushing it a little faster than I normally would is to look for mid-throttle oscillations, jitters in the video, and just any other issues that might arise when I fly faster than I normally would. And on this tower, I think you just saw a crow fly off, which was pretty cool. Or a raven or something, I don't know. And as you can see, the flight seems pretty darn smooth. Now, as always, and everybody pretty much says this when they tune a quad, there's probably room for improvement on the PIDs, as I don't think anybody could ever get a tune perfect unless they just get lucky. So I'm sure that this can benefit from further tuning from somebody who really knows what they're doing, but in all honesty, it took me a good solid week of flying, trial and error, to get this tune where it is. It was a lot of blood, sweat, and tears. INAV, in my opinion, is just not very easy to tune simply due to the fact it's limited by a 1K PID loop. That's right, that's like the old NAS 32 days back when Betaflight was just starting out, or most people were flying clean flight. 1K PID loop. That's what INAV runs off of. And you can get a pretty darn good tune on 1K, but the moment you start to deal with any kind of turbulence and wind, then the tune just shows its flaws. It doesn't handle prop wash at all, so flight characteristics and your skill level is going to dictate how smooth your footage comes out. Just dealing with the limitations is something you have to accept. However, as you can see, this flight footage is very smooth, relatively speaking. There's no jello and there's very little jitters. Now the DVR you might see skip a beat every once in a while. This is just a limitation on my phone using an Android receiver, but it seems to keep up. Even though it loses a few frames, it still stays in sync, so that's what that's all about. The skipping in the video has nothing to do with the drone, that's just the DVR. You know, I'm not trying to brag about this build or anything. I'm simply posting this to help anybody who's interested or maybe currently struggling with a 6-inch INAV build. People like me who simply want that GPS fail-safe capabilities as a big stress relief, but are having a really hard time getting the tune to work. I know the feeling because, to be completely honest, I searched YouTube for 6-inch INAV builds for a few weeks, and I couldn't find anything that flew anywhere close to this smooth. Everything I saw for INAV 6-inch builds was really shaky and jittery and just flew bad. And I'm not saying they're not out there. I'm sure there's other 6-inch INAV pilots who've got some incredible smooth flying drones. I just couldn't find any. So I really hope that this video will be able to help you guys. Now I'm going to put the PIDs in the description, of course, so that way if you have something close to my build, it'll hopefully get you close to a solid tune. Now watch this, something I've been wanting to try for a while. How will return to home handle a steep banking maneuver? Right there you saw me bank heavily to the left, kill the throttle and activate return to home. And as you can see, it leveled out really quick. Now let's go even more aggressive. Gain some altitude, go into a steep no throttle dive and hit return to home, and watch this. If that doesn't give you confidence for a fail-safe situation, I don't know what will. That was a full dive. Now I know I wasn't picking up maximum speed, but I was still pretty aggressive on that dive. And I activated return to home, and the flight controller, compass, GPS had absolutely no problem immediately leveling out and putting the drone in the correct orientation to start heading back home. That gave me incredible confidence with this setup. Really nice to know that if you have to make an aggressive maneuver far away and you hit a fail-safe, that the flight controller can handle some aggressive situations. Okay, first off guys, just something I want to get out of the way. As far as my transmitter is concerned, in a few of my videos you're probably going to see me using antennas off of a pigtail. I added a pigtail to my QX7. I want to let you guys know right away, this is not something you need to do and may not give you any benefit whatsoever. I have personally flown 2 miles straight out on a wing with the stock antenna on a QX7, okay? So as long as your antenna placement is good and you have a nice high antenna away from other electronics, I know that you can personally get 2 miles with some leeway on the stock QX7. So when you see this, don't feel like it's something you have to do to get mid to long range flight. This is something I did to see if I would get an advantage. And so far I personally haven't noticed one. Although I haven't tried to push further than 2 miles out since I've flown on the stock antenna. When I push about 1.5 miles out, I noticed that the RSSI values in my OSD with both of these antennas appears to be about the same as it was with the stock antenna. I'm guessing that, see, these are Wi-Fi antennas I got off Amazon. They're supposed to be on the 2.4 gigahertz band, but I'm thinking maybe they're not tuned to the proper length. They could be a multi-band antenna, those stupid 5.8 and 2.4s or something like that. So my guess is that I'm using the improper antennas. However, I did fly with this patch antenna and this INAV build 1.5 miles straight out the other day. So although I might not be getting a benefit from the external antennas, I do know that they're still giving me good performance, okay? So just to let you know, you do not need aftermarket antennas on something like a QX7. Your antenna placement on the multi-rotor or flying wing is really the big deal. The higher you can get it and the further you can get it away from electronics, the better your reception is going to be. I also would like to point out, if you're running something like the XSR receiver or the R-XSR receiver, the antennas that those come with are not at the proper length for a long-range build. I can guarantee you right away that the XM Plus receivers, or at least the original ones with the proper length 31mm antennas, get much better RSSI than the R-XSR or the XSR receivers. Now that doesn't mean you shouldn't use those receivers, it just simply means that you'll need to trim the shielding to the proper length, so you'll end up giving it a few more millimeters. But at 31 millimeters on the antenna, you should get your maximum performance and really good flight range on a stock antenna, okay? Yeah, so that is actually something that I haven't done with these builds, but I know from personal experience that if you trim the shielding to the proper length, you get better range, as I've done it with 5-inch builds to test out, and even some of the big channels have tried it out and found out that the proper length antennas get better range. However, know that I was still getting the good range and good RSSI values with the stock antennas on the R-XSR, which were unmodified. I do need to go and modify them so I can get better range. It's just something I haven't done yet. Now this build here is a Betaflight build, which is very similar to this one as far as the setup, but there are different components. I just have it here as a comparison. We're not really going to go over it in this video, but this is about a 7-minute flyer, very good flight performance, very smooth, and this is our INAV build right here. So what I'm going to do here is I'm going to work my way from the outside of the quad in, and this is going to be a little long, so if you are still interested in something like this, grab a cup of coffee, because there should be some information in here that, even though I don't know everything about it, might help you just by seeing something or hearing something. Maybe it'll remind you about something you need to do or give you some information you simply didn't know. All right, so from the outside in, and then we'll talk about reasons why I chose certain components and thoughts, things I might change. Now, when I originally wanted to build this, I had intended twin-bladed props. I did not originally want to use tri-bladed props. So my motor combination, my motor ESC combination for tri-bladed props, had I done this all over again, would be a little bit different. It would actually be closer to what's here on the Betaflight build, which we'll go over in a minute, just for comparison reasons. So keep that in mind. I originally intended twin-bladed props. So the motors I chose to go with that was the 2207 EMAX LITE SPEC, or SPEC LITE motors. They're, from what they say, they're an efficient motor designed for 6-inch builds. They have low kV, these are 1900 kVs. So they're designed for nice long flight times with good performance, but not like super punchy or anything. And they're also really lightweight motors. They're going with the whole no bottom bell thing or cover, whatever. I'm happy with them. They're smooth, they fly fine, no problems. The problem with running dual-bladed props, I tried 3 different sets. I tried Gem Fans, HQs, and Racecraft twin-bladed 6-inch props. And these are all good props that I don't really have an issue with. The problem is maybe it's just a combination of those props with this frame, but every twin-bladed prop I put on these, no matter what the tune was, I had jello in the video. Whether the tune was good or the tune was bad, there was always jello in the GoPro. I simply couldn't get rid of it, you know, and it limited me. It means I had to fly in the morning or the afternoon, because if I tried to fly it in the middle of the day, the video was unusable. It was just way too much jello. So I decided to try tri-bladed props, no pun intended, and found out immediately, as expected, and most of us already know, that the jello was immediately eliminated. Well, I've mentioned this in previous videos, so I'll just go over it again real quick. The problem with tri-bladed props, as most of us know, or so we're told at least, is they're not as efficient as twin-bladed, so you're going to sacrifice some flight time. You do, however, gain more flight performance, but you also draw more amps out of your motors. Because I don't push these builds, I'm never anywhere near full throttle unless it's an emergency situation. I'm always just cruising around. It's not an issue. My motors don't get hot. They do get warm, but they don't get hot, and I'm not drawing anywhere near my maximum amp capability on these ESCs according to my OSC or OSD. Also, the fact I noticed, at least for me, it's a lot easier to tune a build with tri-blades, whether you're on INAV or Betaflight. I just noticed that tri-blades fly better. The craft is smoother, easier to tune, more responsive. So if you have a better tune with tri-blades than you would with twin blades, you might still get about the same amount of flight time, because keep in mind, as mentioned before, when you don't have oscillations, you're wasting less energy, because when the quad oscillates, you know, it has to compensate by adding wasted power. So keep that in mind. The ESCs I chose were a Lumenier 30 amp BL Heli S, and I went with BL Heli S because, as far as I know, INAV doesn't support D-Shot, so I didn't see a reason to go with the D-Shot ESC, as BL Heli S, as Joshua Barr would put it, is proven ESCs that simply work and have pretty much most of, if not all, the bugs ironed out. So I decided Lumenier. They had great reviews. They're a solid company for ESCs, and that's what I went with. 30 amp, nothing special. Like I said, had I known I was running tri-blades, I probably would have got a little bit bigger motors and maybe 35 amp ESCs. That's if I intended on pushing it. But like I said, cruising around, not a problem. Get the big old brick of a battery out of the way real quick, and it's just a China Hobby line 1800 milliamp 70C4S, okay? Nothing special. These are inexpensive batteries. I think I bought them at like $22 a piece, and I've seen them as low as $18. Just depends on what time of the day you want to buy them, because it seems like they have sales on their batteries like every day. It's just going up and down. It's like popcorn. that was a bad analogy. But anyways, that's what that is. Nothing special. Flite Test recommends flying this with like some big 2800 milliamp battery. It's like $50 a piece. And you get like 13 minutes of flight time, but I cannot afford those batteries. Okay, for FPV, I'm using a FOXEER Predator camera. I'm actually using that on both of these builds. I'm not a stickler for cameras, but I will say that when they say the dynamic range of these cameras is better than CCD cameras, they're not lying. That is not hype. You can see everything in the shadows with these cameras. I don't know if I would choose them for a racing build, you know, but like I said, I really don't care about cameras as long as the picture is good. And I really like the Predator camera. It's connected to a Mach 2 video transmitter. And I really like this video transmitter, except for one issue, which I mentioned in the video. Every time I shut it down, and that's on both of these builds. At first I thought it was an INAV thing until I did beta flight, and it's the same. Every time you shut it down, it defaults back to 25 milliamp. Not a big deal. Ever since I found out exactly how far you can fly on 25 milliwatts, I found myself not really caring so much about it anymore. But keep that in mind. If you do plan on pushing a real far range with this, you're gonna have to remember to go in and change your milliwatts. Or just choose a different video transmitter. But I really like that one. Smart audio, and it's cheap, and it got really good performance. It's connected to a PAGODA, and here I want to show you this mounting solution that I came up with. I'm kind of proud of this. Hopefully it'll help somebody in the future. Maybe it's overcomplicated, maybe I'm overthinking this, but this is just something I was able to do. I wanted to get the FPV antenna as high as I possibly could. I had concerns at first that maybe it'd affect the GPS, but apparently it doesn't, because these are on such different frequencies. So that's what it is. Anyways, to get it as high as I possibly could, what I did was I took two big zip ties, put them around the top plate, brought them up, folded them over, put a piece of heat shrink around the fold, and then a zip tie in between them just like this. And what this does is it holds it really solid. There's no way that this is going into the props unless you hit something that literally pushes it into the props, like a tree or something like that. But in flight, this is nice and solid, really high. Now, obviously, this is not a mounting solution that you would use on your normal freestyle or racing. This is just something for long range where you get it as high as possible on a solid mount. Okay? So there, that's what that is. The issue I was having before is I had it coming out the back, and it only sat about this high. And when I would turn around to come home, the entire frame and the battery and the camera blocked my video signal. So I could fly far away, no problem, but when I turn around to come home, big problem. Now, it's set up in such a way that when I come home, I get the best video signal. And in my opinion, that's kind of the most important part. When it's time to come home, that's when you need the best video you can possibly get. Now, I get great video from all angles of this, but when I'm flying far away, I'll reach my limitations first, and then when I turn around, I'll get very clear video. I might have over-explained that, but you guys get the idea, and you know why it's important if you're flying far away. The GPS unit. This is from the Banggood's US warehouse, and it is by far the best GPS unit I've ever used. I have 3 of them, and none of them have given me problems. They lock on to like up to 20 satellites sometimes, and they'll do it within a minute, usually getting like 8 satellites in the first 10 seconds of being powered on. Important to remember that with this unit and most GPS units, the compass is flipped upside down and rotated 180 degrees. Or maybe 90 degrees, I can't remember, it's one or the other. So in the configurator, if you're having loiter issues and toilet bowl issues, you gotta remember to go in the configurator, tell the flight controller to flip the compass and then rotate it 180 or 90 degrees. You just have to mess with it to find out what's proper. I also shortened the stack. See, this is the spar. It's a fiberglass spar that holds the GPS above the electronics, and I played around with this a little bit to find where I could get it as high as possible to keep it away from all the electronics, but not so high that it gave me vibrations. Originally, when I used it at stock height, was about this high, I think about 2 or 3 inches higher than it is now. What was happening is when I look in black box, I noticed a very large spike in vibrations at about 60 hertz. And since it was the only quad I had that's ever done that, I put 2 and 2 together and figured out it was this vibrating It was just a resonant frequency, and obviously that gave me very bad handling characteristics, and I was worried that maybe that might heat up the motors, although I didn't really have an issue with motor heat, but still bad flight characteristics. So I shortened it an inch, and the vibrations went down another inch, and the vibrations went away completely, and I still had good GPS hold. One issue I ran into when I first did that was some inconsistencies with the compass. Sometimes it would properly hold its location, and sometimes it would be kind of weird and rotate. So what I found out what was happening is when I brought it down, it was too close to the power cable, which normally I just plugged into the top of the battery and held it down with a Velcro strap like this. So what I just started doing is I moved it forward a few inches, and now I plug it into the front of the battery like so. Recalibrated the compass, and ever since, that was about 3 weeks ago, I've had fine, great flight characteristics. I have no GPS issues so far. What else? The flight controller is a MATEK F405. It's an all-in-one power distribution board flight controller, SD card reader. It's got these little jello vibration dampeners, or those gummies. I really like this flight controller, and it's natively supported by INAV. All the features work on it, no problems. It's got a lot of UDARTs, so you can connect a crap ton of stuff on this. If you're doing something bigger and you want to do like a 3DR radio, no problem. You have the UARTs to do that, as well as the GPS, compass, smart audio, and if you were doing like a Betaflight build, you could do the telemetry from the ESCs. It actually has a pad in each corner for ESC telemetry. I just really like that flight controller. Okay, I think that's it for the receivers. I'm using 2 receivers on both of these builds. Ever since I found out about the redundancy setup, I've been all over that, because these receivers are so tiny and lightweight now that personally for me it makes sense to put 2 in a build, especially in the more expensive builds. And what I've done with this one is not ideal, but what I've done with this one, in my opinion, is better. So instead of showing you how I have this one set up, I'm going to show you how I have this one set up, because if I was to do it over again, I would build it like this, because I built this one after I built this one, so I learned a few things. So we're gonna bring this Betaflight build over here and just pretend like this is the INAV build, because this is how I would set it up. Okay, I have the R-XSR receiver in the back, and I don't think it matters which one's in the back or the front. This is just where I have it. I have one antenna pointed in such an angle that it lines up perfectly with my home antenna on my receiver or my transmitter when I'm doing basic cruising flight. Okay, I have another one sticking out the side right here off of a standoff, and it's in such an angle that it stays out of the prop, no problems, and you can rotate it to just touch the base of the motor. You can pull it out the back wherever you want it. But this is just how I have it set up, so that in banking maneuvers I have good polarization there. On the front, I have another one sticking pretty much straight up, and this is just for coming home, an extra redundancy antenna to kind of complement this one in case you have issues, because in my opinion it's more important to have better reception up than it is out the sides, because very, very seldomly am I ever going to be doing steep dives and banks when I'm far away. I'm just way too concerned about fail-safes when I'm far away from myself. And I also pointed another one straight out the front, so I have diving polarization. Maybe I'm overthinking this, guys, but basically I have all my bases covered. I have a dive, a roll, and 2 antennas off the top for maximum reception. Yeah. So there you go. And so far, no problems with range. I actually have never had a failsafe with this yet, and I've pushed it pretty darn far, 1.5 miles out in some pretty sketchy conditions, and have not had a failsafe. I will tell you this. My radio, I had to turn off the telemetry warnings, because when I get about 1 mile out, the telemetry just starts going nuts. It said, telemetry lost, telemetry recovered, telemetry lost, telemetry recovered. But I'm looking at my OSD and I've still got like 55 RSSI. The lowest I ever really get when I'm pushing it far out is like 45, 42. I never see it go below 40 when I'm really far away. But what I think is happening is a combination of the improperly tuned antennas and the fact that to get telemetry from the quad to the radio, the receiver, which is actually a transceiver, has to transmit a signal, and it's obviously the signal coming out of the quad, and correct me if I'm wrong, is weaker than the signal coming out of your radio. So you get a certain distance away from your radio and you no longer receive a signal from the quad, but the quad is still receiving a good solid signal from the radio. That's just something to keep in mind. And because this system was not really designed to fly out as far as we're pushing it nowadays, that's why I think this telemetry thing happens. So when you start getting telemetry lost, telemetry recovered, blah, 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 back and forth, but you see your RSSI is at like 48 and 50, don't freak out too much over it. I've still had solid control, 1.5 miles out, no fail-safes at all. I'm not saying it can't happen. When you dive below a tree line by accident and you hear telemetry lost and your video goes out, there's a pretty good chance you're going into a fail-safe. But when you're open air and you still have a video signal and you hear your radio say the telemetry lost, I don't really think there's an issue with the connection, but that's just my thoughts and opinions, okay? So don't go pushing it out, listening to your telemetry warnings on the first flight thinking that you're gonna be okay, you know, always be real cautious. That's it, guys. That is the full breakdown of this build. Any other thoughts and opinions I have that I can think of? Let's see. Not really, just one other thing that people might ask. On my INAV build, you'll notice I run a flat camera angle, and on my Betaflight build, I run the 30 degrees. The reason for this is my Betaflight 6-inch is more of the cruising freestyler, mid-range, not long-range. So obviously in this case I'm going faster, I'm doing flips and rolls, power loops and all that good stuff. But I don't do that with the INAV build because it's just not what I've designed it for. I've designed it for just going out, cruising long range, skimming over the tops of trees, and that's it. And when you're doing that, you tend to find yourself elevated, and when you're elevated, the angle is not really as important because you generally see more of the scenery, you want to see more of the ground when you're high up in the sky than you do the horizon. Of course, this is just my personal preference, but I found that when you're flying far away and you're high above objects, camera tilt's not really that important. I personally want to know the attitude of the quad when I'm flying further away. So there's that. Okay guys, I hope you enjoyed the video, and despite my rambling on random parts of this, I hope you have found some relative useful information. And I'll see you in the next video, and I'm just going to try and keep getting this to fly better. Not really further. I think this caps out. Perfect conditions, 2 miles out, 2 miles back is all you're really going to get.